right. Algebra 2, lecture 11:30 and 12:1, OAS A2A15. The student will solve radical equations in one variable, checking for extraneous solutions. An extraneous solution is a solution that you derive by solving an equation, oftentimes as a result of squaring both sides of an equation, which is what we're going to be doing today. That it comes about through solving the equation. You haven't made any mistakes, but it doesn't actually make the equation true. It's an extraneous solution. So we have to check for that, make sure that the solution that we come up with actually works to solve the equation. You have to plug it back in, make sure it makes a true statement. What we're going to be doing is isolating the radical. They're going to be radical equations, as it says up here. The student will solve radical equations, has a square root symbol in it, in one variable and check for extraneous solutions. So we're going to isolate the radical. We're going to square both sides of the equation. And when we do that, sometimes you get extraneous roots. I don't think we'll get any today, but in the next lecture we'll run into a couple, possibly. Then we're going to solve for the variable. So when we square both sides of the equation, that's going to get rid of our radical symbol. We'll solve for the variable. Then we'll check to make sure that our solution actually works, okay, or solutions. So that's the plan. That's how we're going to do it. Here we go. We're going to solve, check for extraneous solutions. Now look at this. The first thing I want to do is isolate this radical. See, it's got this -3 that's multiplied by it. First little dot here, isolate the radical. That means get rid of anything that's on the same side of the equation as the radical. Since I have a multiplied -3, I'm going to divide both sides by -3. I'll go ahead and show it this time. Usually I would just do that in my head. 12 divided by 3 is 4. And negative divided by negative is positive. So this side will turn into +4 is equal to, these will cancel out and it will be positive because negative over negative, leaving me with the square root of 9v minus 2. So we have isolated the radical. Now we're going to square both sides of the equation, and when we do that, this radical will disappear. Squaring both sides, when you have a square root, if you square it, the square undoes the square root, just like addition undoes subtraction in an equation, multiplication undoes division, and vice versa. Squaring undoes, so to speak, the square root symbol. It'll make it disappear. So I'm going to square both sides. When I do this side, this will cause this to disappear, and whatever happens over here happens. Here we go. This turns into 16 if I do my arithmetic correctly. And I'm really good at making mistakes in arithmetic, so bear with me if I make any mistakes. This will make this disappear. It will undo it, so to speak, and leave me with 9v minus 2. And now I'm going to solve for the single variable. And then I'll check to see if it actually works in the equation. So I'm going to add 2 to both sides. I'll go ahead and show that. Normally I would just do that in my head. And then divide both sides by 9. We got 18 divided by 9 is 2. Those cancel, yields v. And that's our solution, and we're going to check to see if it actually works. I'm sure it will, but we'll just check to make sure. Plugging in a 2, that's 18 minus 2 is 16. The square root of 16 is 4. 4 times -3 is -12. So we check, it's not an extraneous root, so that's our solution. And I'm nearly sure, yeah, that's correct according to the key too. So yay! Well, let's do another. Again, I'm keeping this in mind. I'm going to isolate the radical, square both sides of the equation to get rid of the radical. Then we'll have just an algebra problem that we could solve using Algebra 1 pre-algebra techniques and check for an extraneous solution. So I look at this equation. I want to isolate this radical. Well, it's already isolated. So step 1, so to speak, is already done. So the next thing I'm going to do is square both sides of the equation. As soon as I do this, this radical disappears. But I've got to square the other side just to stay in balance. 8 squared is 64. I almost said 16, so watch out for that. 8 squared is 64 is equal to -8 minus 9x. And now I've got a pre-algebra problem. I'm going to add 8 to both sides and then divide both sides by -9. So if I add 8 to both sides, this will yield 72 on this side. And on this side, this -8 will disappear, leaving me with -9x. I just added 8 here and it disappeared. Added 8 here and it turned into 72. Now I'm going to divide both sides by -9 rather. I'll go ahead and show that. I don't know why I'm showing it. And 72 divided by 9 is 8. If one of the numbers is negative, then the entire quotient is negative. And our value is x. Our variable is x. And if I haven't made any mistakes, when I plug this into the original equation, it should work. Let's get rid of this real quick. And if it doesn't work, then it's extraneous or I've made a mistake. So this is -8 minus 9 times -8. That is 72 minus 8 is 64. The square root of 64 is 8. So this works when I plug it in, so it's not extraneous, and I haven't made any mistakes. So yay, that's 2 of them, and the answer key says that. So it's good. So far so good. Let's take a look at another one. Hopefully this is making sense. Again, I want to isolate my radical. I want to get rid of this multiplied -6. So I'm going to divide both sides by -6. Then I'm going to square both sides to get rid of that radical, the radical symbol. The square root symbol, you'll hear me say radical symbol. It means the same thing. Square root and radical. I want to get rid of the radical symbol, and then I'll multiply both sides by 10. That's my plan, to get v by itself. So the first thing I'm going to do is divide both sides by -6. This will yield 10, positive 10, because -60 divided by -6, 60 divided by 6 is 10. If both are negative, then the entire quotient is negative. These will cancel, turning into a fancy form of 1. For the same reason, 6 divided by 6 is 1, negative divided by negative is positive. 1 times this radical is this radical. Okay, now I want to square both sides to get rid of this radical. I square this side just to make this radical symbol disappear. I square this side just to stay in balance. If I square one side, I've got to square the other side. That gives me 100 is equal to v over 10. The radical symbols just disappeared. Okay. And now I'm going to multiply both sides by 10. That will give me 1,000 on this side. Put a little comma there. Is equal to, and if I multiply this side by 10, they'll cancel and leave me with v. So I multiply both sides by 10. Got 1,000. And now I'm going to check to see if that works. V over 10, that's 1,000 over 10, that's 100. The square root of 100 is 10. 10 times -6 is -60. So that does work. So yay. No extraneous roots so far. I don't think we're going to have any today in this lecture, and I don't think there are any on the worksheet that's attached to this lecture. There will be on the next lecture, I'm nearly certain. Okay, we're looking at this. We want to isolate the radical. I look at that on this side of the equal sign. The only thing here is the radical. So I don't have to isolate it. It's already alone. There's nothing multiplied by it. There's nothing added to it. So I'm just going to get rid of it by squaring both sides. Again, I'm appealing to these little bulleted items I wrote down. This is what's going through my head. I want to isolate the radical, get rid of the radical by squaring both sides. Then I'll be left with a simple algebraic equation that I'll solve using Algebra 1 or pre-algebra techniques and check for extraneous solutions. You'll hear me say roots. Roots and solutions are kind of interchangeable concepts. Here we go. I square both sides. That gets rid of this radical symbol. And 4 times 4 is 16. I'm going to add 4 to both sides. That makes that turn to 0, and on this side I have to add 4, that turns it into 20. Now I'm going to divide both sides by that -4. It's supposed to be -4, let's make it look more like a negative. There we go. So divide both sides by -4, and that will give me x on this side. And if I divide this side by -4, it'll give me -5. That's our solution. We're going to check to see if it's extraneous by plugging it back into the original equation. I'm just paying attention to the black part. This is -4 minus 4 times -5, so that's -4 plus 20, because -4 times -5. So -4 plus 20 is 16, and the square root of 16 is 4. So that is not an extraneous root either. I believe that's all of them. Yep. So in a nutshell, we're just going to run through these little bulleted items. We're going to isolate the radical if we need to. Sometimes you'll need to, sometimes you won't. We're going to square both sides of the equation, and that will make the radical symbol disappear. Then we solve the remaining algebraic equation using Algebra 1 or pre-algebra techniques. And then we're going to check to make sure that the solution actually makes the equation true. Plug it back in and check. Okay. And that's what it looks like. You can do this, solving radical equations.